right? So today in the class, I'm going to explain unbalanced assignment problem. Okay, so already we have discussed unbalanced transportation problem. So what is unbalanced transportation problem? If the sum of available amounts not equal sum of required amounts, then the problem is unbalanced transportation problem. So whereas in assignment problem, unbalanced assignment problem means the number of rows not equal number of columns of the assignment matrix. That means number of persons not equal number of jobs, for example. Then that problem is called as unbalanced assignment problem. Okay. So the cost matrix of an assignment problem is not a square matrix. మా టయానికి రండి, టయానికి రావాలి కదా, మధ్యలో డిస్టర్బెన్స్ కష్టం. Okay, right. So the cost matrix of an assignment problem is not a square matrix. So not a square matrix means number of rows not equal number of columns. That means number of persons not equal number of jobs, for example. So rows means persons, columns means jobs. So if number of persons not equal number of jobs, then that problem is called as unbalanced assignment problem. To solve this problem, we have to balance the problem. How do we balance? We add either rows or columns, whatever needed, with zero cost. Okay, so in such cases, dummy rows or dummy columns with zero performing costs are added. Okay, so that is the way to balance an unbalanced assignment problem. Okay, so here we will be given one more question. So what is unbalanced assignment problem and how do you balance an unbalanced assignment problem? So we balance an unbalanced assignment problem by adding dummy rows or columns with zero performing costs or with zero costs. Okay, so that is the way to balance an unbalanced assignment problem. Okay, so remember, unbalanced assignment problem means number of persons not equal number of jobs or number of rows not equal number of columns in the assignment matrix. But whereas in transportation problem, unbalanced transportation problem means the sum of available amounts at origins not equal sum of required amounts at destinations. That is the unbalanced transportation problem. Okay, so already we have discussed how to balance an unbalanced transportation problem. Okay, right, now consider the example. Right, this problem, a company is faced with the problem of assigning 6 different missions to 5 different jobs the costs are given below. Find the optimal assignment. So we have 6 jobs, 1 2 3 4 5 6, sorry, 6 missions, 1 2 3 4 5 6 and 5 jobs, A B C D E. These are the performing costs. So here given the costs are given below. Okay, so the entries in the matrix represent costs. So cost means we try to minimize the performing cost. So it is a minimization problem. Okay, right. So how do we start? First, verify whether the problem is balanced or unbalanced. So here we have 6 rows and 5 columns. So number of rows not equal number of columns. So number of rows 6 and number of columns 5. So number of rows not equal number of columns. The problem is unbalanced. Next, how to balance the problem? So we require one extra column. Since there are 6 rows and 5 columns, so we require one extra column, that is dummy column. Okay, so we introduce a dummy job or dummy column with 0 performing cost. So add dummy column with 0 cost. Okay, so take the matrix. First 5 columns as it is, and the last column is 0 column, that is column containing zeros. So this last column is dummy column with 0 cost. Okay. Okay, right. So now we use the Hungarian method to solve this problem. So here we have 6 rows and 6 columns. Okay. So what is Hungarian method? First step, we find possible assignments for rows and observe the matrix. In each row, the minimum performing cost is 0, 0, 0. That means the row minima is 0 for each row. So by subtracting 0, we get same values. So in this case, we need not subtract row minimas from the entries of that row. Okay, already since in each row, the minimum is 0. Okay, so you need not subtract row minima from the entries of that row. Okay, next we find possible assignments for columns. For that, we find column minimas. So here write column minima. So first column minima 30. Next second column minima 36. Third column minima 31. Fourth column minima 32. Fifth column minima 34. And sixth column minima 0. So these are column minima values. Okay, right. Now obtain the next matrix or table by subtracting the minimum of each column from the entries of that column. Okay, right. So from first column subtract 30. Okay, so 30 minus 30 0. 43 minus 30 13. 34 minus 30 4. 39 minus 30 9. 32 minus 30 2. 36 minus 30 6. Okay, first subtract 30 from first column. Next subtract 36 from second column. 39 minus 36 3. 37 minus 36 1. 41 minus 36 5. 36 minus 36 0. 49 minus 36 13. 42 minus 36 6. Similarly, subtract 31 from third column. So fill the remaining columns. 31 minus 31 0. 32 minus 31 1. 33 minus 31 2. 43 minus 31 12. 35 minus 31 4. 35 minus 31 4. Similarly, subtract 32 from fourth column. And similarly subtract 34 from fifth column. And subtract 0 from last column. So last entries all are zeros. Okay, right. So this matrix shows the possible assignments for rows as well as for columns. Okay, so for first row there are 3 possible assignments. So the 0 entries represent possible assignment. Okay, so first mission can assign to job A or job C or dummy job. Okay, and second mission has this possible assignment. Okay, like that. So the 0 entries represent possible assignments. Okay, now we have to fix the assignments. How do you fix the assignments? We draw minimum number of lines to cover zeros. Okay, so draw minimum number of lines to cover all the zeros. Draw minimum number of lines to cover all the zeros. Okay, right. Start with first row. Observe first row. First row contains 3 zeros. So more than 1 zero. Skip first row. Next, second row contain only 1 zero. Right. Row 2 contains only 1 zero. Circle that 0 and fix the column, that is cross off dummy column, that is 6th column. Next, third row also contain only 1 zero. So row 3 contains only 1 zero. So this is the 0 in the row 3. Since you need not consider this one, since already this column is fixed, that is this column is crossed off. Okay, so third row contains only 1 zero. Circle that 0 and fix that column, that is cross off column 5. Next, come to fourth row. Fourth row contain more than 2 zeros, sorry, more than 1 zero. Skip fourth row. Fifth row no zero, and sixth row no zero. Okay. So observe the table. Still there are zeros not covered by lines. So observe the table. Still there are zeros not covered by lines. Then go for columns. First column. So first column contain only 1 zero. So column 1 contains only 1 zero. So circle that 0. Circle that 0 and fix row, that is cross off row 1. Next, second column contain only 1 zero. This is second column contain only 1 zero. So column 2 contains only 1 zero. Circle that 0 and fix that row, that is fourth row. So cross off fourth row. Then third column contain no zero. Fourth column contain no zero. Okay. Now observe whether all zeros are covered by lines. Okay. So these are uncovered entries. So here there is no 0 entry, and also these are uncovered entries. Here also there is no 0 entry. Okay, so all zeros are covered by lines. Okay, right. Verify the optimality condition. What is optimality condition? Here number of lines drawn. So 2 horizontal lines and 2 vertical lines. 2 horizontal lines and 2 vertical lines. So number of lines drawn equal 4. That means we have made only 4 assignments. Okay, and a number of rows 6. So number of lines drawn not equal number of rows. So assignment is not completed. So present assignment is not an optimal assignment. The assignment is not completed. So we have to improve the assignment. How do we improve the assignment? We take minimum of uncovered entries. What is minimum of uncovered entries? What is the minimum of uncovered? Uncovered entries are all these are uncovered entries. These are uncovered entries. Among these, minimum is 1. Okay. So minimum of uncovered entries equal to 1. Minimum of uncovered entries equal to 1. So add 1 to the entries in the intersection of covered rows and columns. So similar steps, and subtract 1 from the uncovered entries. And the entries remain in covered row only or covered column only remain same. Okay, so write the new table. Okay, right. So first row, observe this previous table. So all these 4 entries remain same since they lie in covered row only. Okay, so 0, 3, 0, 6. Okay, next. So these 2 entries lie in covered row, in the intersection of covered row and covered column. So we have to add 1 to these 2 entries. So 6 plus 1, 7, 0 plus 1, 1. So here observe this entry. So it is, in the previous case, it is one of the possible assignments. Now it is removed. Since this entry become non-zero, that means this possible assignment is removed. Okay, right, next. These 4 are uncovered entries. So we have to subtract 1 from these 4 entries. So 13 minus 1, 12, 1 minus 1, 0, 1 minus 1, 0, 3 minus 1. Observe these 2 entries. So these 2 are 2 new possible assignments. So previous they are non-zero entries. Now they become 0 entries. So these 2 are new possible assignments. Okay, right. Next, these 2 entries lie in covered column only. So they remain same, 4, 0. Next, these 4 are uncovered entries. Subtract 1 from these 4 entries. 4 minus 1, 3, 5 minus 1, 4, 2 minus 1, 1, 9 minus 1, 8. And these 2 remain same since they lie in covered column only. So they remain same, 0, 0. Okay, next. These 4 entries also remain same since they lie in covered row only. So 9, 0, 12, 0. Next, these 2 lie in the intersection of covered row and covered column. We have to add 1 to these 2 entries. So 2 plus 1, 3, and 0 plus 1, 1. So again observe this entry. In the previous, this is possible assignment. Now it become unassignment possible. That is, the previous possible assignment is removed here. Okay, right, next. So these 4 are uncovered entries. Subtract 1 from these 4 entries. 2 minus 1, 1, 13 minus 1, 12, 4 minus 1, 3, 8 minus 1, 7. And these 2 remain same. They lie in covered column only. So 3, 0. Next. These 4 entries are uncovered entries. Subtract 1 from these 4 entries. 6 minus 1, 5. Again 6 minus 1, 5. 4 minus 1, 3. 12 minus 1, 11. And these 2 entries remain same since they lie in covered column only. So 8, 0. Okay, so this is the new table with new possible assignments. Okay, again next we have to continue the same process. We have to fix the assignments. For that, draw minimum number of lines to cover all the zeros. Okay, right. For that, start with first row. Observe first row. There are 2 zeros in first row. That is more than 1 0. So skip first row. Second row also contain more than 1 0. Skip second row. Third row contain more than 1 0. Skip third row. Fourth row also contain more than 1 0. Skip fourth row. Fifth row contains only 1 0. So fifth row contains only 1 0. This is the 0. So row 5 contains only 1 0. Circle that 0 and fix column. So cross off sixth column. So row 5 contains only 1 0. Circle that 0 and fix column. So cross off sixth column. Next, sixth row, no zero. So still there are zeros not covered by lines. Then go for columns. First column. So first column contain only 1 0. So column 1 contains only 1 0. Column 1 contains only 1 0. Circle that 0 and fix row. So cross off first row. Next, second column. Second column contain more than 1 0. Skip second column. Third column contain only 1 0. This is 0. So column 3 contains only 1 0. Column 3 contains only 1 0. Circle that 0 and fix row. That is cross off second row. Next, come to fourth column. Fourth column also contain only 1 0. So column 4 contains only 1 0. So this is the 0. Circle that 0 and fix the row. Cross off fourth row. Cross off fourth row. Next, come to fifth column. We have to observe these three entries. So fifth column also contain only 1 0. So column 5 contains only 1 0. So this is the 0. Column 5 contains only 1 0. This is the 0. So circle that 0 and fix row. That is cross off row 3. Okay. Now observe the uncovered entries. So these are uncovered entries. In these entries, there is no 0 entry. So there is no 0. So that means all zeros are covered by lines. Okay. Right. So now verify the optimality condition. How many lines we have drawn? So 2, 3, 4. 4 horizontal lines and 1 vertical line. That is 5 lines. Or observe the circled 0 entries. 1, 2, 3, 4, 5. Okay. So number of lines drawn is 5 and the number of rows 6. So both are not equal. So number of lines drawn not equal number of rows. Number of lines drawn not equal number of rows. Still assignment is not completed. We require 6 assignments. So here we have made only 5 assignments. So since still assignment is not completed. Now we have to improve the assignment. Same process. We find minimum of uncovered entries. So these are uncovered entries. Among these, minimum value is 1. So among these, minimum value is 1. Okay. The minimum of uncovered entries equal to 1. This is minimum of uncovered entries is 1. Same steps as usual. Add 1 to the entries in the intersection of covered rows and columns. Subtract 1 from the uncovered entries. Okay. All right. So observe the previous table. So all these entries lie in covered row only. So all these entries lie in covered row only. So all these entries remain same. All these entries remain same since they lie in covered row only. Okay. So all these entries remain same since they lie in covered row only. Okay. So all these, write these entries. Okay. Right. Next. So observe these entries. These 4 entries lie in the intersection of covered row and covered column. Okay, so these 4 entries lie in the intersection of covered row and covered column. Okay, so we have to add 1 to these 4 entries. So first this entry 1 plus 1 2, 0 plus 1 1, 0 plus 1 1, 1 plus 1 2. So observe these 2 entries become non-zero. In the previous table these are 2 possible assignments. Now they have removed. Okay, right, next. Now these entries, these are uncovered entries. We have to subtract 1 from these entries. We have to subtract 1 from these entries. Okay, so 1 minus 1 0. So this is new possible assignment. 12 minus 1 11, 3 minus 1 2, 7 minus 1 6, 3 minus 1 2, and this remains same since this lie in covered column only. So this entry remains same. Next, 5 minus 1 4, 5 minus 1 4, 3 minus 1 2, 11 minus 1 10, 8 minus 1 7. This also remains same. This lie in covered column only. Okay, so this is the table with new possible assignments, and some old possible assignments are removed. Okay, again we have to fix the assignments. So for that, draw minimum number of lines to cover all the zeros as usual. So draw minimum number of lines to cover all the zeros. Right. Observe first row. First row contain 2 zeros. So that is more than 1 0. Skip first row. Second row also contain 2 zeros. Skip second row. Third row contain only 1 0. Third row contain only 1 0. So row 3 contains only 1 0. Row 3 contains only 1 0. Circle that 0. Since it is row, so we have to fix column. So cross off column 5. So cross off column 5. Next, fourth row contain 2 zeros. Skip fourth row. Fifth row also contain 2 zeros. Fifth row also contain 2 zeros. Sixth row only 1 0. So row 6 contains only 1 0. Row 6 contains only 1 0. Circle that 0 and fix column. So cross off column 6. Okay, still there are zeros not covered by lines. So go for columns. Observe first column. First column contain 2 zeros. These 2 zeros. Skip first column. Second column also contain 2 zeros. Second column also contain 2 zeros. Third column also contain 2 zeros. And fourth column contain only 1 0. This is fourth column contain only 1 0. So column 4 contain only 1 0. Column 4 contains only 1 0. Circle that 0. Since it is column, we have to fix row. Cross off fourth row. Cross off this row. Cross off this row. Okay, next. Fifth and sixth columns are crossed off. You need not check. Still there are zeros not covered by lines. Again, go for rows. Go for first row. First row contain 2 zeros. Skip first row. Second row also contain 2 zeros. Third row, no 0. Fourth row crossed off. Next, fifth row. Fifth row contain only 1 0. This is fifth row contain only 1 0. So row 5 contain only 1 0. Row 5 contains only 1 0. Circle that 0. Since it is row, fix column. So cross off column 1. Cross off column 1. Next, sixth row. Sixth row contain no 0. Okay. So skip the sixth row. Still there are zeros not covered by lines. Still there are zeros not covered by lines. Again, go for columns. First column already fixed. Okay. Second column. Second column contain only 1 0. This is second column contain only 1 0. Okay, right? Column 2 contains only 1 0. This is column 2 contains only 1 0. Circle that 0. Circle that 0. since it is column, we have to fix row. So cross off second row. Cross off second row. Next, come to third column. Third column contain only 1 0. So these two entries, this entry, this entry. So third column also contain only 1 0. So column 3 contains only 1 0. Column 3 contains only 1 0. Circle that 0. Since it is column, fix row, cross off first row. Okay, next, fourth column, no 0. Now observe the table. So these are uncovered entries. And these are uncovered entries. Okay, so there is no 0 entry in the uncovered entries. That means all zeros are covered by lines. Okay, right. Now observe the circled 0 entries. So these 3 and these 3, 6. That means we have drawn 6 lines. So 1, 2, 3 horizontal lines and 1, 2, 3, 3 vertical lines. Okay, so therefore, number of lines drawn equal number of rows. So we have drawn 6 lines and there are 6 rows. So number of lines drawn equal number of rows. So we have made all assignments. Okay, so assignment is completed. Assignment is completed. Assignment is completed. So present assignment is an optimal assignment. Okay, right? So optimal assignment is the circled 0 entries represent assignments. These are, this is 1 and this is 1, this is, and this is, this is, this is. So these are assignments. Okay, observe the original matrix. So machines are 1, 2, 3, 4, 5, 6 and jobs are A, B, C, D, E. So first take 1 to 6 machines. 1 to 6 machines. Okay, so this is 1 to third column. That is 1 to third column. This is, so 1 to C. So 1 is assigned to C. So mission 1 is assigned to job C. This is. Okay, next two. Second row, second column. So second row, 2, second column, B. So mission 2 is assigned to job B. So 2 is assigned to job B. Next, third row, fifth column. Okay, so third to fifth, that is E. Okay, so job mission 3 is assigned to job E. Mission 3 is assigned to job E. And the corresponding cost is 34. Okay. Next, fourth row and fourth column. Okay, so here fourth row to fourth column. So mission 4 is assigned to job D. Mission 4 is assigned to job D. Okay, next, fifth row, first column. That is fifth row, first column. Okay, so mission 5 is assigned to job A. So 5 is assigned to job A. Okay, this is. Next, sixth row, sixth column. So sixth column is dummy column. So that means mission 6 is assigned to dummy. So mission 6 is assigned to dummy job. So mission 6 is assigned to dummy job. Okay. Now the minimum performing cost. So minimum cost is add the corresponding entries from original matrix. Okay. So this is 31 and 37 and 34 and 32 and 30. Okay. So you need not consider last assignment, that is mission 6 to dummy job. So this performing cost is 0. So you need not consider this one. Okay. Right. So minimum cost equal 31 plus 37 plus 34 plus 32 plus 32, that is 166. So this is the minimum performing cost, and this is optimal assignment of missions to jobs. Okay. So this is the way to solve an unbalanced assignment problem.